Hey everyone, and welcome to the Explainer. So let's talk about a classic microservices headache. You do everything right, you perfectly separate all your data, and then, boom, you need a report that brings it all back together. If that sounds familiar, you're going to want to stick around. We're about to show you a really clean and powerful way to solve this using a neat feature in JPA, the Java Persistence API.
All right, so let's just dive right in. This is a wall that pretty much every single developer hits when they're working with microservices. You know the drill, right? You follow all the best practices, you isolate your data into these nice, neat little boxes, and then out of nowhere, the business needs a report that spans everything. So, what do?
Okay, before we jump straight to the solution, let's just take a second to make sure we're all on the same page about the problem itself, because it really all stems from a core principle of microservice design.
I mean, this is the golden rule, right? One service, one database. Each microservice owns and controls its own little world, its own database. And that's great. It gives you independence, scalability, autonomy. It's a fantastic pattern. But it comes with this really challenging side effect.
Yeah, because even though your services are separate, the business logic isn't. The data is still connected. A user in one database is connected to a product review in another, which is connected to a product in a third. So how do you bridge that gap without creating this tangled, horrible mess of slow, complex API calls?
And you can see this play out perfectly in a super common scenario, like an e-commerce setup. Just imagine, you've got a user service. It's got its own database, a product service with its database, and a review service with its own data. They're all independent, living their best lives. But then, management comes knocking. They want a report that links one specific user to all of their reviews and the products they reviewed. Uh-oh.
So, here's the thing. At the database level, the solution is actually pretty clear. If we could just, for a moment, pretend those service boundaries didn't exist, we know exactly what we'd want to write.
And this right here, this is the goal. One single, beautiful, elegant SQL query that just joins tables across the product service, the review service, and the user service schemas. This is the absolute most efficient way to get this data. One trip to the database and you're done. It's the dream, isn't it?
Okay, which brings us to the million-dollar question for us Java developers. Your standard JPA relationships, your at-one-to-manys and so on, they're just not going to work here. Why? Because the tables are in totally different schemas. So how in the world do we execute this incredibly powerful query and, this is the crucial part, map the results back into nice, clean Java objects?
Well, it turns out JPA has a couple of secret weapons up its sleeve, perfectly designed for this exact scenario. It's a two-part solution that, honestly, feels almost like magic once you see it all working together.
So, the first piece of our puzzle is this annotation, @NamedNativeQuery. What this lets us do is take that big, awesome, cross-schema SQL statement we just drooled over, embed it safely right inside our code, and just give it a simple, reusable name.
But okay, defining the query, that's only half the battle. The second and equally important part is telling JPA what to do with the results when they come back. And that's where @SQL results set mapping comes in. You can think of it like an instruction manual. It tells JPA exactly how to turn the raw, messy results from the database into our nice, neatly structured Java objects.
Okay, so the really crucial part here is seeing how these two annotations work together. It's a coordinated effort, it's a team sport, and when we combine them, we get a super elegant solution. Let's walk through how to actually implement this.
We can break this whole thing down into just 3 straightforward steps. First, create an object to hold our results. Second, define the query and its mapping. And finally, create the repository method to make it all work. All right, step 1. First things first, we need a place to put our combined data. So we create a simple POJO, a plain old Java object. Now the key thing to remember here, and this is important, is that this is not a JPA entity. It doesn't map to a table, there's no @entity annotation, it's just a simple data container, like a bucket, for the fields we expect back. Product name, username, review content, all that good stuff. Okay, step 2. We just pick an existing entity. Honestly, it doesn't matter too much which one, but products.java is a perfectly good candidate. Then we just slap our 2 key annotations right on top of that class. This is where all the magic happens. We define the native query itself, and we tell it how to map the results into that new reviews by user POJO we just created. Now this is where the magic connection happens. Look closely here. The @NamedNativeQuery has a property called resultSetMapping,
and we've set it to the string reviews by user. Now that string, that is the critical link. It points directly to our @SQL result set mapping, which has the exact same name. That's it. That's the secret handshake that tells JPA, hey, use this mapping for this query.
And now for the final step, which is just beautifully simple. You go to your products repository interface and you just declare a new method. And here's the magic. The method name, findReviewsByUser, exactly matches the name we gave our @NamedNative query. That's all you have to do. You don't write any implementation code. Spring Data JPA sees those matching names and just wires everything up for you automatically. It's amazing.
So, okay, after those 3 steps, what have we actually achieved? What's the big deal? Well, this is where we see the real awesome payoff for this little bit of setup.
I mean, just look at the difference here. The hard way, you're making multiple API calls, multiple database calls, you're manually stitching data together in your service layer. It's a lot of complex, brittle code that's a nightmare to maintain. But the JPA way, we get one single super efficient database call, we get automatic mapping straight to our Java object, and all that ugly complexity is just hidden behind one clean, simple repository method. It is a huge win, both for performance and for keeping your code clean.
So if there's one thing you take away from this, it's this. Native queries aren't just for some weird, obscure edge cases. They are a first-class, frontline tool for building powerful, read-only reports in a microservices world. So the question I want to leave you with is, where in your own architecture, where are those data silos that you could break down with this exact pattern? Think about where this could simplify your code. Thanks for watching.